All right, so Chapter 2 test review here for Honors Pre-Calculus. Again, we've got our review session. We're going to just jump right into it. First problem we want to take a look at, it says that we're supposed to algebraically factor f of x equals x to the fourth minus 49x squared, and then we want to find the zeros. So as we're going to factor this, again, that means that I can factor x squared out, which is going to leave me with x squared minus 49, which very conveniently happens to be a difference of 2 squared. So I know that's going to split x plus 7, x minus 7. So to completely factor this out, x squared can be broken down x times x plus 7 times x minus 7. So this has been completely factored now. So in order to find the zeros, I set f of x equal to 0. And now, again, it's just going to be that calculation where I set each individual factor equal to 0 and solve. So simple here. X equals 0, x equals 0. If I were to set x plus 7 equal to 0, I'll get x equals negative 7. If I set x minus 7 equal to 0, I'll get x equals positive 7. But those are my zeros, where x plus 7, and x minus 7 will be my factors. Second problem we want to take a look at, it says that we're supposed to find the x and y intercepts for the function f of x equals x squared plus 9x plus 7. So if we want to find, again, just kind of in general terms, if you wanted to find the x-intercepts, what we're going to do is we're going to let the y, or the f of x value, equal 0, and then solve for x. If you're trying to find the y-intercept, exact opposite. Now you're going to let the x values equal 0. So in order to complete this, we do have the option in this particular problem. Again, when I'm looking at trying to find the x-intercepts, we would have the option looking to my original function f of x and attempting to factor it. I'm pretty certain when I'm saying that this is not going to factor nicely. There are no factors of 7 that add up to 9. So my next option would be, well, let's complete the square and make this work. And it would happen, it would work, but we're going to be dealing with, and it'll be necessary for us, I should say, to work with fractions. So I'm not loving that idea either. So instead, maybe we could look at setting this up as 0 is equal to x squared plus 9x plus 7. And now we can go about actually using the quadratic formula in order to get there. So the quadratic formula, in case you've forgotten, is the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So in cleaning up, basically in substituting in, I should probably say, b is 9, so the opposite of 9, plus or minus the square root of, we're looking at 9 squared minus 4 times a is 1, times c, which is 7. It's all under the radical. And this is all over 2 times a, or 2 times 1. All right, so to clean up, we have negative 9 plus or minus the square root of, I know that 9 squared is 81. Let's see, negative 4 times 1 times 7 is negative 28. All of this is over 2. There. So to clean up a little bit further, I have negative 9 excuse me, plus or minus the square root of 53 under the radical over 2. And we could try and try, but that's as good as it's going to get. So we just found that our x-intercepts are going to be located at negative 9 plus or minus root 53 over 2. As for the y-intercepts, I think we're going to notice this is going to work out a little bit easier for us. What we need to do is actually evaluate f of 0, meaning in my original function, which was x squared plus 9 times x plus 7, everywhere that we saw an x, we're going to place a 0, and we can clean this up again easily here. 0 squared is 0, 9 times 0 is 0, plus 7. We're going to say that our y-intercept is going to be located at 7. So we should probably identify y-intercept. We're talking 0, not 7. All right, next slide. We want to determine the end behavior of the function. So remember that when we talk about the end behaviors, it's all, again, the first thing that we want to focus on or look at is going to be the overall degree of the function. So if the degree is even, we want to treat, or use, I should say, the exact same pattern, I suppose, that my parent function f of x is equal to x squared. We know that f of x equals x squared is a parabola opening upward. Again, if we know and remember our parent functions, we're talking about looking at something like that. So all even functions are going to follow that same pattern, where the two ends are going to be pointing in the exact same direction. And if the lead coefficient is positive, then they're both going to be pointing upward. If they're both negative, then it's going to reflect and they're going to point downward. Let's try not to use f. Let's use g of x. If we had another function, g of x is equal to x cubed. Now, obviously, that has a degree that is odd. So now we're looking at the parent function for the cubic, and you'll notice that first major difference is going to be that the two ends are now pointing in opposite direction. Again, if the lead coefficient is positive, it's going to follow this exact pattern of left end down, right end up. We could get fancy with our terminology, saying as x approaches negative infinity, that just means to the left, or as x approaches positive infinity, that just means to the right. I'm a believer in why make it harder than it needs to be. All right. So jumping over here to number 3, part A. Again, all of this is great, but this is what we really care about. I'm noticing that the degree is even, and the lead coefficient is positive. So we know that's going to follow the exact pattern of my quadratic. So on the left end, we're going to be rising. On the right end, we're also going to be on the rise. Going upward. For part B, now we're noticing that we have an odd function. So now we're talking about the cubic parent function. But I'm also noticing that I have a lead coefficient that is negative. So now my left end and my right end, we can't just use blindly to look over, or blindly assume, I should say, that we're going to use the cubic function in its exact state. We have to think about, since the lead coefficient is negative, we're going to be dealing with the reflections. On the left end, that's what was rising, and on the right end, that's what was falling, or decreasing, or however it was that we want to say. I'll say falling, that's fine. We don't use technical here, I suppose. Part C, again, I'm noticing negative 4x to the fourth, in function h. So again, the first thing we care about completely is the fact that the degree is 4, which is even. So we're thinking more parabolic in terms of my overall sketch. We know that anytime the degree is even, that your two ends are going to be going in the exact same direction. In this particular case, with that lead coefficient being negative, that means that they've reflected and they're both falling or going downward. So again, both on the fall. Lastly, we have a lead coefficient that is positive along with a degree that is odd. Anytime we have an odd degree, we're going to be going in opposite directions. This time, since we have a positive lead coefficient, then we will look the exact same as our parent cubic function. So on the left end, we are falling. On the right end, we are rising. So it falls to the left, rises or increases, it goes up on the right. So next up, number 4, we want to put the quadratic in vertex form and identify the vertex and x-intercepts. So this was like number 1 on your quiz for 2.1 through 2.3. Some of us are going to want to pay very, very close attention to this material here. We're talking now about completing the square and getting out of the standard form and getting into vertex form. So if we go to complete the square, I've got f of x on the left side. I want to get this constant moved over as quickly as possible. So I have f of x minus 8. That's going to leave me with negative x squared plus 2x. When we go to complete the square, we're just not ready yet because I have that lead coefficient of negative 1. I need to have a lead coefficient of positive 1, which tells us that we have to factor the negative 1 out. And now we have a slightly different setup. Again, negative 1 on the outside, remaining inside with x squared. Now, again, positive coefficient 1 now, minus 2x. So on the left side, we still have f of x minus 8 is equal to, on the right side, we still have negative 1 times quantity x squared minus 2x. But now when we go to complete the square, remember that it's all about this pattern of b divided by 2 quantity squared. That's what we're going to complete the square with, which is simple as long as we can know and understand what b is. B in this case is going to be the value in front of x, so we'll say negative 2. Divide that by 2 and square it. So negative 2 divided by 2, of course, is negative 1. Squared is positive 1. Get all this stuff out of the way. So if we add 1 on the right side, we better add 1 on the left side, except I'm not actually adding 1 on the right side. We've got to remember that we have this scalar multiplied through. It doesn't quite look like it, but I'm actually adding negative 1 to the right side. So I have to add negative 1 to the left side. So cleaning up the left side, f of x negative, or minus 8 minus 1 is going to be negative 9, is equal to negative 1 times. So now, the whole reason for doing this is I need to get the binomial squared. So we're going to find x minus 1 quantity squared. We want f of x all by itself, so I'm going to add the 9 back over. So in doing this and finalizing my vertex form, f of x is equal to negative 1 times quantity x minus 1 squared plus 9. So when we need to put into vertex form, there it is. As a reminder, vertex form, f of x is equal to a times the quantity x minus h squared plus k, which upon getting into this form, now we know that a is equivalent to negative 1. H is always the amount that's being subtracted from the x. So h is 1. K is the amount being added on the outside. So it looks like k in this case is going to be 9, which is very, very helpful for us because we were asked in the directions, back here, to put into vertex form, done. Then we were supposed to identify the vertex. So the vertex is nothing more. I should write this out. The vertex, all that we're going to do is identify hk. So in substituting in, we've said that h is positive 1, k is positive 9. So once we know that our vertex is located at 1, 9, is there anything else? We're supposed to find some x-intercepts as well. So off to the side, remember, if we're trying to find x-intercepts, that means that we're going to put a 0 in place for f of x. So 0 is equal to negative 1 times quantity x minus 1 squared plus 9. So I'm going to begin by subtracting the 9 back over. It's negative 1 times quantity x minus 1 squared. Now I need to divide this negative 1 over. Negative 9 times, divided by negative 1 is going to be positive 9. My negative 1s are going to cancel out, leaving with x minus 1 squared, where I want to find the square root. So the square root of 9, don't forget, is plus or minus 3. That's equal now to x minus 1. If I were to add the 1 back over, what this literally means, again, is x is equal to 1 plus or minus 3. So if we did the addition, I'm sorry, let's start with the subtraction. If we did the subtraction, 1 minus 3, we get that x is equivalent to negative 2. If we did the addition, 1 plus 3 is going to tell us x is 4. So in terms of x-intercepts, we're talking about these points at negative 2, 0, and positive 4, 0. But again, these are my x-intercepts. All right, so with that being said, again, that was the material or information that we were supposed to calculate. Now we're supposed to put all of this together on the graph. So I'm going to start with my vertex being located at 1, 9. So over 1 up 9, we're right here. I'm then going to move to the fact that my x-intercepts are at negative 2 and positive 4. So I have an intercept here at negative 2 as well as positive 4, and something like that. And we're going to finalize our sketch somewhere along this man. Again, I suppose I maybe should have talked about it at this point as well. But when we calculated our intercepts, we're going to find our zeros at negative 2 and positive 4. They both only showed up 1, so they have a multiplicity of 1, which is odd. That's the reason why we're going straight through. We're not turning or bouncing on those points. But that's what we were looking for in number 4. Okay, number 5, we want to go ahead and do some division here. So bad news, we cannot do synthetic division in this particular problem. We've got 8x to the 4th plus 26x cubed minus 9x squared plus 14x plus 24. And I'm going to divide by 4x plus 3. I'm looking at the time on the podcast. I don't know if I have it in me to do that problem in 45 seconds. So I'm going to go ahead and stop here, and we'll pick it up on the next slide.